In this video, we're going to learn how to solve exponential equations using the change of base and logarithms. What is a change of base? For example, you are given 8 and you want to express in terms of a different base. You can express it in terms of the base 2. 2 to the power of 3 is 8. Or if you have 16, and you want to express it in terms of the same base as the previous number. So 2 to the power of 4. When we're solving equations involving exponential expressions, we can completely drop the base if the base is the same and only solve the equation in terms of the exponents. Say you have an equation 3 to the power of x equals 9. You want to determine what exponent 3 needs to be raised to in order to get 9. Well, you can probably figure it out because you know that 3 squared is equal to 9. But what if this was a little bit more complex? One way to solve this equation is to express both sides of the equation in terms of the same base. So 3 to the power of x is equal to 9 can be expressed as 3 squared. Once you have the same base, you can drop the base and only solve the equation in terms of the exponents. Therefore, x equals 2. 3 squared equals 9. Let's look at a more complex example. 5 to the exponent of 3x plus 2 is equal to 25. We have to do the same thing. We need to express both sides of the equation in terms of the same base. So 5 to the power of 3x plus 2 is equal to 5 squared, since 25 is 5 squared. Once we have the same base, we can drop the base and only operate exponents. So 3x plus 2 is equal to positive 2. And then we have a linear equation, and we can solve it for x. Subtract 2 from both sides. This will eliminate it here, and it will eliminate it here as well. So then we'll get 3x equals 0. And then divide by 3. X equals 0. We can always check by substituting. If we sub in x back into the left side, 5 to the power of 3 times 0 plus 2 is the same as 5 to the power of 2, 5 squared. So we have solved this equation correctly. You may have equations that have fractions, and then you need to think of those fractions as something that was raised to a negative exponent. So 1 over 16 is the same as 1 over 2, since we want to express it in terms of the same base, to the power of 4. And since I have the reciprocal, it means that originally the exponent 4 was negative 4. So I can write it as 2 to the x equals 2 to the power of negative 4. And then from here, x equals negative 4. Let's look at another example. 3 to the power of x is equal to 9 to the power of x minus 1. Let's express 9 in terms of base 3. 3 to the x is equal to 3 squared, and this squared, this 2, this exponent of 2, has to be multiplied by the whole existing expression, so we put it in brackets. And then it will be distributed over both terms inside that bracket. So then we'll get 3 to the x is equal to 3 to the power of 2x subtract 2. Once you have simplified everything in terms of exponents and the base is the same, drop the base and only solve the exponents. So x equals 2x subtract 2. And let's bring the x over. So we'll get x equals positive 2. Sometimes it's really difficult to determine the exponent to which two of the same bases were raised. For example, if you have 3 to the x equals 100, can you express 100 as base 3 to a nice integer exponent? No, it's very difficult. It's impossible, in fact. So when we have a situation like that, we need to use logarithm. A logarithm is essentially the expression that determines the exponent to which any base was raised to in order to get a certain answer. So in order to express this equation in terms of the logarithm, we say that log of base 3 that produces a certain number equals the exponent. So normally, any general log is given on your calculator as log a or log x. The base here is 10. And if you want to change the base, I will show you how to do that in a second. There is another button on your calculator. It's ln. And this is a natural log. You're not going to use it until later in math. So for now, you will have to use the log button. When you change the base, and it's not just log of a number, but a different base, log base 3, then in order for you to solve for x, for the exponent, you need to do log of the answer that's being produced divided by log of the base. And now the base, the 3, is a large number. It's not a subscript anymore, like in the previous expression. So on your calculator, you're going to determine log of 100 using the button log a or log x or whatever variable you have there, divided by log of 3. And x equals approximately 4.19. It's a long decimal, right? So we'll have to round. 4.19. What does that mean? It means that 3 to the exponent of 4.19 is equal to approximately, let's use this quickly, equal sign 100. It's in fact equal to 99.8, which we can round up to 100. So a logarithm is a way for you to determine what the exponent is when you cannot change the base of one of the values or more than one of the values in the exponential equation to solve just in terms of exponents.